In this project, we will simulate the external airflow over a mountain. The geometry of this model is designed in ANSYS Design Modeler software. The model of the present project is meshed in ANSYS meshing software, and the mesh type used for this geometry is unstructured. Under the General Setup tab, you can see different buttons from scales to units. By clicking on a scale, a new window will appear showing you the domain extents of your geometry. Also, under the view length units section, you can see the default geometry units, which is meter in this project. Also, under the scaling section, under the mesh was created in, you can change the settings in order to activate the scaling factors beneath that. For example, your geometry and mesh was designed in a software which its default unit was millimeters. By activating these scaling factors, you can change this factor to your desired factors in order to set the length to the appropriate unit. As you can see, after double-clicking on the energy button, in the appeared box, we have enabled the energy equation since we want to account for the temperature changes in our computational domain. And if you click on this outlet boundary, you can see that the type of this boundary is defined as pressure outlet. If you click on Edit button in the appeared window, the most important point you should pay attention to is the gauge pressure, which is defined to have a value of 0 Pascal, meaning that our airflow will exit our computational domain to the atmosphere. Now if you select each of the wall boundaries and then click on Edit button, in the appeared window under the Momentum tab, you can see the stationary wall motion along with no slip shear condition are defined for these walls. Now if you click on the Thermal tab for this wall, you can see the temperature thermal condition is defined and the value of temperature over this wall is defined to be equal to 300 Kelvin. We may also change the under relaxation factors. These factors may be between 0 and 1. Based on the simulation and the project we are doing, we may change these under relaxation factors. But remember that the values set in here are the recommended values for the project, and we highly recommend you to not change these values. After double-clicking on the initialization button, a new window will appear showing you different methods of initialization, hybrid and standard. Now in the standard initialization method, you get to choose the first amounts and values for the first iteration of the simulation progress. These values refers to the values used in the first iteration of the simulation progress, and if you choose the values for each parameter wisely, your simulation progress will finish sooner. It should be mentioned that you can also choose the first values or the initial values by just clicking on the Compute From drop-down list and clicking on one boundary. For example, by clicking on Compute From All Zones, the software will automatically average the values in different zones and boundaries and put those values in the initial values for the software. Now in this part, we have extracted 3D and 2D contours by the means of CFD Post software. In this slide, you can see the velocity distribution over a plane which is placed on the middle section of our computational domain. Also, you can see that behind the mountain, there is a region with a decreased velocity indicating that vortices are being generated in that region. And in this slide, you can see the temperature distribution over the same plane, and you can easily see that the temperature has increased near the mountain surface. And finally, for example, in order to extract the pressure distribution over the surface of the mountain, you can just simply change the locations from plane number 1 to the mountain wall surface, and then by changing the variable section to the pressure, and then by just clicking on the apply button. And finally, in this slide, you can see the pressure distribution over the surface of the mountain. Finally, a summary of different settings and setup that we have used in our project is presented to you in the slide.
Obtain the mesh file and also the full training movie by purchasing this product.
The study of natural phenomena has always been of interest to researchers. The purpose of this project is to study the airflow and its heat transfer on the surface of the mountain that it encounters in its passage, which is also effective in determining the air passage for the aircraft. In this project, the air enters the fluid domain with a velocity and temperature of 8 meters per second and 297.5 Kelvin respectively. The energy model is activated due to the nature of the flow, which is of the external flow type, and considering the airflow velocity, which has consequences such as flow separation and vortices behind the mountain, the K-epsilon standard model has been used to analyze the turbulent flow. The geometry of this model is designed in ANSYS Design Modeler software and consists of an airflow inlet, the mountain itself, and three different pressure outlets, including top and side walls and the main outlet. The model of the present project is meshed in ANSYS meshing software, and the mesh type used for this geometry is unstructured, and the element number is equal to 1,250,044.
To benefit from Mr. CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.